So I'm going to take a look at all the possibilities that we can have for the exam in diagrams, algebra and truth tables. I'm going to start off with everything that deals with and. I'd like to show you all on one sheet of paper, but it's just too large. But there's not too many for you to sort of learn. You can either generate them from scratch or just commit them to memory. Either way will be good. But I'm going to probably shrink down my writing to begin with, and because it's rather large, and try and show you each and every one. So let's start off with and. Okay, we've just done that one, A and B and the output Q. And I'm not going to do the programming language. Okay, I will do the programming language. I want to do the Boolean algebra though, so that is Q equals A and B. Let's do the programming language, but I'm not going to put the ifs in. I'm just going to write A and B. So there's my first and we've done the truth table for that, but I will repeat it. But I want to take you through all the possible options of having sort of two levels. The first one is on the A one. If I put a NOT gate on the A before I hit the AND gate, there are my two inputs. But now I've got a NOT gate on the A leg. And that would be written in algebra as Q equals NOT A and B. And in programming it would be NOT A and B. So I've got another one. If I had no bother on the A input, but on the B input I also had a NOT gate. So there's my B. So all I've done is put the NOT gate on the B leg this time. The algebra for that would be Q equals A and NOT B. And the programming language would be A and NOT B. Fairly straightforward. And finally, for this one, I can have, I'm only going to look on the input at the moment. I'll look on the output later. If I had sort of knots on both legs before I hit the AND gate. There we go. The algebra for that would be Q equals NOT A and NOT B, and the programming would look like NOT A and NOT B. So hopefully they're sort of making sense at the moment. I'm going to do the truth table for all of those and show you how to manage when we've got an extra item on the leg. So let's do that. So this one's going to start off with A, B and Q. Remember the pattern. I'm not going to keep going through it. I'm just going to say, I'm just going to write it down. And so we've already done this one. It's only true when both are true. This one, now I'm going to do something a little bit different. So I'm actually going to do A, then I'm going to write NOT A, and I'm using the symbol just to sort of keep it squished in, and then I'm going to have B before Q. So I'm going to write my A's down normally, 0, 1, 0, 1, and I'm going to write my B's down normally, 0, 0, 1, 1. But what I'm going to AND is not the A and the B, I'm going to AND these two together. So I want to work out what NOT A is first, and NOT A is just the opposite to A, so that would be a 1, that would be a 0, that would be a 1, that would be a 0. So I've worked out my not A. Then I'm just going to sort of ignore this column here and just work on these two here. So I'm just going to do the A and B. Sometimes instead of Q, they might actually write the actual algebra on the top. But here we go. Let's do this one. Let's keep it in red. So remember, with an and, only when both are true will the result be true. 1 and 0, well, that's false because we've got a 0 there. That's false because we've got 2 zeros. That one is true. That one is false. So that is my output Q for these two inputs. So the truth table is different to A and B. Notice where the 1 appears and why. Let's do the next one. So this one was A, B, and I'm going to do the same thing. I'm just going to write a little not B there, okay, to manage that one. So I'm going to invert it to make the work easy for me. And finally a Q. So I'm going to write down my A's, 0, 1, 0, 1. B's, 0, 0, 1, 1. Not the B. So that's going to be 1, 1, 0, 0. I'm only looking at the B. I'm not looking at the A at all. And now I'm going to AND these two together. Okay. So let me just underline it as I go. 0 and 1 is 0. 1 and 1 is 1. 0 and 0 is 0. 1 and 0 is 0. And that is my truth table for this diagram, this algebra, or that programming statement. And finally, let's take a look at this one, where both of them are knotted. So let's do that one, not A, not B, and Q. You don't need to do this step, but it may help you to do so. I find it, particularly when we've got more than 3 inputs, 4 inputs, when we're doing the truth table, is to work on 2 things at a time and produce a result and then work from the result. It's much easier. So let's go 0, 1, 0, 1, 0, 0, 1, 1. So let's do the not A. That's going to be 1, 0, 1, 0. Let's do the not B. 1, 1, 0, 0. It's just the opposite of that. Now I can work out my Q. Let's stick with red. 1 and 1 is 1. 0 and 1 is 0. 1 and 0 is 0. 0 and 0 is 0. So that is there, the result. I'm underlining it for all of those double input logical gates. So in the next video I'm going to do the OR version, but I will be coming back to this a bit later because I want to see what happens when I put a NOT on the end of these, but only keeping it at 2 levels.